Okay, before we move forward with any more examples, let's just go ahead and determine these different cases. So we're going to have 4 cases I'm going to share with you. The first one is distinct linear factors, and that's the one we've done some examples on up to this point, just so you're familiar with the process and the idea of partial fraction decomposition. So we've done one like this with distinct linear factors, so we would just separate this into an a plus a b, and then we would use our methods for solving a and b. We also saw one where we have 3 different ones, so then we would say an a plus a b plus a c, and same idea. So let's look at case 2. Okay, so here we can see that this is a repeated factor. It's to the third. So when that happens, we're going to have the buildup. So you'll have a over x plus 1 to the first power, b over x plus 1 to the second power, c over x plus 1 to the third power, so we'll take care of that, and then we have d over x. Just to get another idea, if I have this, of course this can be rewritten, because this is difference of perfect squares, as x plus 2 x minus 2, and then this x minus 2 is just carried down. Well, this now gives x minus 2 a power of 2. So first of all, we have a over x plus 2, which is this one, and then we have the buildup here because we have x minus 1 to the x minus 2 to the first power, x minus 2 to the second power. Our third case would be a situation like this, where you can see you have quadratic factors on the bottom. Of course, these are not difference of perfect squares, so we will have a linear form in the top, so you'll have an ax plus b. And then over the second one, you would have a cx plus d. Now, if I just had, let's just say an x, I would only have an f here. But what if I had an x squared plus 5? Then I would have an ex plus f. Okay, so this time we have quadratic factors and some are repeated. So this is a quadratic factor and this shows it's repeated. So with this, we need that buildup. So we'll have to the first, to the second, to the third, and this one's just to the first power, so it's over here by itself. Because it's a quadratic factor, we get ax plus b, cx plus d, so on and so forth. Okay, so what if you have different combinations? Let's just look at this one for a second. So this is, we got a square here, so we're going to have a buildup, but this is just a linear factor, so we'll have x, a over x, and then we had that buildup there, so b over x squared. Moving to this one, it's just going to be x plus 1 over c. This is quadratic and it's repeated, so we're going to have this build up to the first power, to the second power, to the third power, to the fourth power, and then the fact that it's quadratic, we have dx plus e, fx plus g, so on and so forth. Okay, so now that we have a better idea of our 4 different cases, let's look at this next one. To start, just by looking at my denominator, first of all, I'm going to have a build up here, so it's going to be over x, and then it's going to be over x squared, and then I just have this term, which is a x plus 3. Now, we'll just have an a b, and a c here, because none of those are, this is not quadratic there. Okay, now, let's take our numerator. Let's just leave it alone. Let's say 2x squared plus 4x minus 5. We'll bring that down. And we also want to have our getting a common denominator. Hopefully you're pretty good at this by now. So I will need ax times x plus 3 plus b times x plus 3. So basically multiply what you need to get this denominator. And then what's our last one? C needs to be multiplied by just the x squared, right? Okay, in doing so, let's just look at this. Remember, this is our common denominator. So if I look at this denominator, it needs another x and an x plus 3. So that's where this comes from. I have x squared, which is this. So all I need is an x plus 3. So we'll multiply times x plus 3. This has x plus 3 and it's missing an x squared, so I'll have c x squared. Okay. Okay, distribute that out. You should finish here. The next thing we want to do is let's kind of group our like terms. First of all, this is an x squared term and this is an x squared term. So if I put them right next to each other and I would pull out an x squared, I would have a plus c x squared, right? Okay, let's look at our x terms. This is an x term, this is an x term. So if I put them next to each other, I could pull out a 3a plus a b. It's an x. Okay, and then what's just left by itself? 3b, right? So just rearrange here and reorder. Now let's drop our left hand side. So we'll have 2x squared plus 4x minus 5. Now let's go ahead and get a highlighter out. So let's do yellow first. The x squared term is going to be this, so I will say 2 is equal to a plus c. Alright, let's do a different color. What about our x term? That would give us 4 is equal to 3a plus b. And then one more highlighter color here. Negative 5 is equal to 3b. Okay, so that's what I'm working with. So if I line those three up and work with those, of course this one's going to be the easiest one to solve for b, and then we're just going to be back substituting until eventually we find all of our missing values. Okay, just to solve with that easiest one first, negative 5 is equal to 3b, so we get negative 5/3. The next thing I'm going to do is write this one down and plug in that value for b. Okay, you'll plug in, add 5/3 to both sides, 17/3 equals 3a, divide both sides by 3, we get 17/9. And then I'll take our first equation over here, plug in a, and solve for c. Okay, plug in that, subtract 17/9 from both sides, 1/9 equal to c. Okay, just so that you could distinctly see your A, B, and C here. Also, if you wanted to simplify this, it could be rewritten as 17 over 9x minus 5 over 3x squared plus 1 over 9 times x plus 3. But this format right here just lets us clearly see our A, B, and C values. Okay, this next one, let's just practice on setting this one up. So the first thing I want you to do is, can this be factored further? Yeah, so factor this further and then just set up the right-hand side. Set up the partial fraction decomposition and don't necessarily solve it just yet. Okay, first of all, rewrite this. This one's just a linear term. This one has a buildup because it's multiples here. So we'll have the x plus 3 to the first power and then x plus 3 to the second power. And this will be what your setup. You will solve this just like we did this previous one. So basically get your common denominator and the numerator there, and then the formatting will be such that you'll have the highlights set up just like this one, okay? And then system of equations to solve. So we're not necessarily going to go through that entire thing. If you want to just know the answers to that, then you would have negative 2 over x plus 1 if you want to practice, plus 1 over x plus 3, and you should get 10 as your c over x plus 3 squared. So if you want to check your work, do that one on your own, you should get that.